This video is going to talk about comparing fractions on a number line. So they give us a number line here, and they're going to ask us to finish labeling the improper fractions on the top and the mixed numbers on the bottom. So on the top, we can see that the improper fractions follow a pattern because everything has been split into fourths here. We have our 0 line and our 1 line and our 2 line, and between each of those whole numbers, or 0, we can see that things have been cut into fourths. There are 4 pieces that are in between the whole numbers. So 0 fourths, this is 1 fourth, 2 fourths, 3 fourths, 4 fourths, or 1 whole. Let's continue that pattern to 5 fourths, 6 fourths, 7 fourths, and 8 fourths. Then let's go ahead and look down below. 0, this is 1 fourth, 2 fourths, 3 fourths. That follows the same pattern as above. But when we get to 4 out of 4, when we start using the mixed numbers on the bottom, 4 fourths is the same thing as 1. So we're going to put a 1 there. Then this is 1 whole because there's 1 whole line there and an extra fourth. We can see that extra fourth. 1 and a fourth is the same thing as saying 5 fourths. 6 fourths, 1 and 2 fourths, 1 and 3 fourths, and then 8 fourths is the same thing as 2. So they want you to go ahead and write an equivalent mixed number. So if we have 7 fourths, we want to turn that into a mixed number, which means we want to make the ln divide. Remember that 7 over 4 is the same thing as saying 7 divided by 4, except to remember what number goes on the inside of the division sign, we're going to make the L on the fraction bar, and you can see that L right there. The number that's inside the L is the number that goes inside the fraction bar, because as you can see, the L kind of looks like a division sign. It just kind of has to metamorphosize into that. So 7 divided by 4, 7 on the inside, 4 on the outside. 4 goes into 7 one whole time. 1 times 4 is 4. And then we have 1 and 3 fourths, which means our answer is going to be 1 and 3 fourths that we're just going to put there because this is going to get all cluttered really fast. 5 fourths, when we make the L, 5 is on the inside, 4 is on the outside. 4 goes into 5 one time. 1 times 4 is 4. 5 minus 4 leaves 1 left over, so we're going to take that one that's all the way to the bottom, move it up so high that it's in the numerator, and that leaves 4 for the denominator. So letter B would be 1 and 1 fourth. Go ahead and give letter C a try all by yourself. Welcome back. Let's talk about what you got. 8 divided by 4, you could set it up like this, or you could know that 4 goes into 8 2 times with nothing left over. You can choose to take that 0, move it all the way up, and put 0 over 4, but it's really not necessary because if I give you 0 fourths of a pizza, you're not getting anything. It's all for me. So we're just going to put the number 2 there. So first thing that we're going to do is we're going to finish this number line and write the mixed number or improper fraction. So let's go ahead and work on this number line. They start at 5 fifths. Why do they start at 5 fifths? They start at 5 fifths because 5 fifths is a fractional 1. And a fractional 1 is a number that's in a fraction form that means the same thing as 1. So if I have a pizza cut into 5 pieces and I take 5 pieces of pizza, I'm taking 1 whole pizza. Let's go ahead and continue this number line. So first, let's go ahead and let's look at what this number line is split into. So we can see it's split into 1, 2, 3, 4, which means that when someone made these awesome slides that 99% of the time look amazing, doesn't quite add up. Because these are split into fourths, which means we need to get rid of this 2 and extend the number line out one more time for 2 to be here, because now we have 1, 2, 3, 4, 5 parts that make a whole. So now that we've done that, we're going to go ahead and extend the number line. 5/5, 6/5, 7/5, 8/5, 9/5, 10/5. And you can see that 10/5 means the same thing as 2, because 10 divided by 5 is 2. Let's see what this would look like as improper fractions. 1 whole plus 1/5 is 1 and 1/5. 1 and 2/5. 1 and 3/5. 1 and 4/5. And then 2. So go ahead and fill out A, B, C, and D just by looking at the top and just kind of see what it is, and we'll talk about it. Welcome back. 7/5 lines up with 1 and 2/5. 1 and 1/5 lines up with 6/5. 1 and 4/5, which is on the scribble, lines up with 9/5. And 8/5 lines up with 1 and 3/5. Isn't math fun? So what number is equivalent to 16/8? So what number is equivalent? Well, remember that equivalent means equal to. So if I say 16/8 equals, chances are that I'm going to go ahead and remember that the fraction bar means division. So that we could say 16 divided by 8, or I could make the L. But I know that 16 divided by 8 is 2. So there we go. Remember that changing an improper fraction to a mixed number is easy when the answer is a whole number. Just divide the numerator by the denominator. Sometimes the numbers are going to divide evenly into a number. Sometimes you're going to get a fraction answer. Don't be thrown off if you do or don't get a fraction answer. It just depends on if you're just talking about wholes or if you're talking about wholes and a part. So go ahead, let's take a look at what number is the improper fraction equivalent to. So you go ahead and try this on your own, and when you come back, we'll talk about it. Welcome back. Let's go ahead and look at this. 24 divided by 4. 24 divided by 4 is going to be 6. So that's my answer. 9 divided by 3. 9 divided by 3 is 3. 8 divided by 2 is 4. 15 divided by 3 is 5. 30 divided by 5 is 6. 18 divided by 6 is 3. And for the bonus, if you tried that, you should have gotten 1,000. How do we find that whole number? What do we do? Well, when we find the whole number, we're dividing. 15 divided by 5 equals 3. So if I try to figure out what number should be here, how do we find that missing number? We have to think about what is the inverse of multiplication. You might think, what's the opposite of multiplication? The correct term is inverse. How do we find the missing number? Well, if we have 3 wholes cut into 5 pieces, we're going to multiply. 3 times 5 is going to equal 15. So over that question mark, we're going to put the number 15, because 3 wholes is the same thing as saying 15/5. So just like we could skip count by 5s until you reach 15, 5, 10, 15, you would do 3 skips the size of 5. Or you could just think 3 times 5. So how would we get the question mark in here from 2 and from 10? So if I have 10 wholes that are cut into halves, what's 10 times 2? 10 times 2 is 20. So let's check our answer. What's 20 divided by 2? 20 divided by 2 is 10. Awesome. So what divided by 2 is 10? 20 divided by 2 is 10. You go ahead, fill this out. When you come back, we'll talk about it. Welcome back. So 2 holes cut into thirds, 2 holes cut into thirds, that's going to be 6 pieces, which means 6 thirds, because 3 times 2 is 6. 3 holes cut into fourths, that's going to be 4 times 3 is 12 quarters. 5, a pizza cut into fifths would just be 5 fifths, but if I have 7 of those pizzas, that's going to be 35 fifths. We don't normally ask for 35 fifths, normally we ask for 7, but you know, math questions and making sure that we understand everything is important. Now, 4 equals what over 8? So if I have 4 whole pizzas, each of those 4 pizzas are cut into eighths. That's going to be, what's 4 times 8? 4 times 2 is 16. That's going to be 32 eighths. That is many slices of pizza. There might be enough for me to share. Go ahead and try these, and we'll talk about it when you come back. Welcome back. So, 8 pizzas cut into ninths is going to be 72 ninths. 12 pizzas cut into fifths is going to be 60 fifths, because 12 times 5, 5 times 2 is 10, carry the 1 is 60. 60 pizzas cut into thirds, 60 times 3, 3 times 0 is 0, 3 times 6 is 180 pieces of pizza. Guys, we might have leftovers, just maybe. 60 pizzas cut into super small 3,000 slices per pizza. You're getting like slivers here. Let's go ahead and figure out what that would be. 3,000 times 60. Well, I don't multiply by 0. That's not going to get me anywhere, so I'm just going to put 0 there as a placeholder. 6 times 0 is 0. 6 times 0 is 0. 6 times 0, that's 0. 6 times 3 is 18. So I end up with 180,000 slices of pizza. Whoa. So let's take a look at what mixed number goes into the box here. So we know that the whole number for this mixed number is going to be what? The whole number is going to be 5, because we start off with 5 here. So all of these are going to have the whole number of 5. How many sections is this cut up into? Not how many cuts are there, how many sections are there? Let's go ahead and count. 1, 2, 3, 4. So because there's 4 sections there, our denominator, our bottom number, is going to be 4. And now that our bottom number is 4, we have 1, 2, 3, 4. So 5 and 1/4, 2/4, 3/4, and 5 and 4/4 is the same thing as 6, because 5 and 4/4 is the same thing as saying 5 plus 1 whole. And 5 plus 1 is definitely 6, the last time I checked. So, how do we find the numerator? Well, we literally just looked at that. 1, 2, 3, 4. So to figure out the numerator, we're going to look at how many steps does it take to get to that line. 1. So our numerator is 1. You remember our whole number? And then our denominator will be fourths, because it's split into fourths. Up here, to figure out what's up here, if we start at 5 and things are cut into fourths, if we're at the whole number 5 and things are cut into fourths, that's going to be 5 times 4, which is 20. So this will start at 20, excuse me, I'm getting ahead of myself. 20, 21, 22, 23, 24. So they want you to complete both number lines, adding mixed numbers on the top and improper fractions. I'm sorry, I can read. Adding mixed numbers on the bottom and improper fractions on the top. You go ahead, try this on your own. look at the whole number, look at how many it's split up into, and then we'll talk about it when you come back. Welcome back. So let's look at letter A. Letter A is split into 1, 2, 3, 4, 5. So it's split into fifths. So our denominator for everything is going to be 5. So I'm just going to go ahead and preload all of this because everything on here is going to be 5. Then we need to figure out how many fifths. So 2 wholes, how many fifths is 2 wholes? 2 pizzas cut into 5 slices each. 2 times 5 is 10. So this is going to be 10, 11, 12, 13, 14, 15. Now I need to figure out the bottom. 2 is going to be the whole number here, so we're going to put 2 in front of everything because we didn't quite reach 3 yet. What should the numerators be? Well, starting at 1. 2 and 1/5, 2 and 2/5, 2 and 3/5, 2 and 4/5. Then we're going to go over to letter B. The whole number down here we can see is 8. We haven't quite reached 9 yet, so it's going to be 8 and something both times. How many cuts do we have? 1, 2, 3 cuts to get to 9, which means all of our denominators will be 3s. My favorite number on the tablet. Ooh, those all look good. So let's do the bottom first. This is 8 and how many thirds? 8 and 1/3. This is 8 and 1/2. Let's go ahead and look at the top. 8 wholes cut into thirds. 8 times 3, that's going to be 24. 25, 26, 27 thirds. So they want you, remember that numbers on the left are less, numbers on the right are greater. Okay, they want you to use the number lines on the previous page to write greater than, less than, or equal. So what I want you to do, go ahead and take a look at what that's going to be, and when you come back, we'll talk about it. Welcome back. So let's go ahead and take a look. Let's convert these all into improper fractions. That's what I'm going to choose to do. So 2 times 5 is 10, plus 2 is 12 over 5. Well, would I rather have 12/5 or 11/5? 12/5 is more, so I want 12/5. Let's take a look at this. 9, what am I going to convert 9 into? Well, it has to be something with a 3 because there's a 3 over here. So 9 times 3, that's going to be 27 thirds. Hey, that's going to be more. So I'm going to have the sign eat the bigger number. Let's go ahead and look at the next one. 2 and 3/5 compared to 15/5. Let's go ahead and convert that into an improper fraction. Or, yes, into an improper fraction. 2 times 5 is 10 plus 3. That's 13/5. What's more, 13/5 or 15/5? 15/5 is more. You know what? I changed my mind. Let's go ahead and convert these into mixed numbers. So when I convert 26 over 3 into a mixed number, I'm going to make the L and divide. Whichever way you did this, absolutely fine. I'm just showing you both ways. So 3 goes into 26 how many times? I know that 3 times 7 is 21. 3 times 8 is 24. So that's going to leave me with 2. So that's 8 and 2/3. Which means, which one's more? 8 and 1/3, 8 and 2/3. 8 and 2/3 is going to be more. 2 and 4/5, 14 over 15. Let's convert 14 over 15 into a mixed number. 5 goes into 14 2 times. That'd be 10. 4 left over, so that's 2 and 4/5. Which is greater? 2 and 4/5 or 2 and... Neither one's greater. They are equal to each other. And then we have 8 and 24 over 3. Let's convert 24 over 3. So that 24 divided by 3. 24 divided by 3 is 8, which is the same thing as 8. How crazy is that? So we're going to put an equal sign. So I want to write improper fractions on this number line. Which denominator should I use? Well, we can see that it's split into thirds. So the denominator that we're going to use is thirds. So let's go ahead and let's set up these denominators, because we know it's split into thirds, and we hopefully know that those are all threes. Now, what we need to notice here is that this number line has negative numbers, which means that our whole number is not going to be -8, because number lines with negative are building towards 0 over here. So 0, 1, 2, 3, 4, 5, 6, 7, and then 8. So these, first of all, they're all going to be negative because they're negatives on the number line. Second of all, we need to go ahead and figure out what the whole number is. And the whole number is going to be -7, which you can almost see squeezed in there. And all of these are also going to be negative. But the thing that we do to figure this out is still the same. So 7 into thirds, 7 times 3 is 21, so that's going to be -21 over 3. 8 into thirds, 8 times 3 is 24, so that's going to be -24 over 3. See, even though I'm forgetting to say it like right now, I still see those negative signs there, and they're super important to remember. So if I have -21 here and -24 here, I need to figure out what's the next numbers. So this is going to be -22, -23, and I can see that the numbers, if they were positive, they're kind of counting backwards. So this would be -7 1/3 here, because it goes 7 1/3, 7 2/3, and then -8. So you go ahead and try to fill in these improper fractions. When you come back, we'll talk about it. Welcome back. Let's go ahead and fill this out. So again, we're working with these pesky negative numbers, which means everything here are going to be negative numbers, which is cool. We know that. I missed a negative sign somewhere. I'm not exactly sure where that's supposed to fit in, so we're just going to erase it and redo it. So we can see that the denominator is fifths. So I'm going to put fifths in here. Oh, they're going to be fifths. There's so much room to write, kids. It's amazing. Then I know that this is going to be -6 all the way. Everything in here is -6 until we get to -7. So that's going to be -6 and something over 5, -6, -6 and something over 5. Everything's going to be negative there. So -30 over 5, -31 over 5, -32 over 5, -33 over 5, -34 over 5, -35 over 5. Look at how, as the numbers get further from 0, they get bigger. Which means that down here, -6, -6 and 1/5, -6 and 2/5, -6 and 3/5, -6 and 4/5, -7. So they want you to go ahead and fill out those number lines. Go ahead and try on your own. When you come back, we'll talk about it. I'm going to go ahead and fill these in here. So -12 over 4, -13 over 4, -14 over 4, -15 over 4, 4, -16 over 4, -3, -3 and 1/4, -3 and 2/4, -3 and 3/4. I don't know what number that is, but you heard me say -3 and 3/4. -15 over 5, -16 over 5, -17 over 5, -18 over 5, -19 over 5. Down here, -3 and 1/5, -3 and 2/5, -3 and 3/5. Don't know why I'm having trouble with that. -3 and 4/5. My ever-repeating apologies that that's so messy. Bonus! What? Here's the only hint I'm going to give you. How many cuts are there? 1, 2, 3, 4, 5, 6 cuts, which means that all of your numbers we'll have 6 as the denominator. So I saw someone write this number line. Take a close look. How do we know that this number line is wrong? Well, it goes from -1 to -2, which checks out because 0 is over here. But if we look, we can see -12/4 is not the same as -1. There's an error in there. And we can also see that the numbers get bigger the closer they get to 0, and that doesn't check out. All of these are incorrect. What's the same as -1? -4/4. Is this split into fourths? Yes, it is. -5/4. -6/4. -7/4. -8/4. Then we go ahead and we do this, -1 1/4, and so on until you get to -2. So which one of these are greater? Go ahead and write that greater than less than sign. Please remember that with negative numbers, you want to give away as little as possible. So these are things that you owe me. You want to owe as little as possible. I'm going to go ahead and convert these into improper fractions. You go ahead and do what makes sense for you. When you come back, we'll talk about it. Welcome back. So -1 3/4. We do the same thing. 4 times 1 is 1, plus 3 is 7/4. Would I rather lose 6/4 or lose 7/4? I would rather lose 6/4. Let's go ahead and do the same thing here. -1 2/4. 4 times 1 is 4, plus 2 is 6. So that's going to be -6/4. Would I rather lose 7/4 or lose 6/4? I would rather lose 6/4. It's the same question. Down here, -5/4 or -1. Now, I can see here that -1 is 1 whole and -5/4 is an improper fraction, which means it has to be more than 1. So would I rather lose 1 or more than 1? I'd rather lose just 1 as opposed to more than 1. The ideal temperature for freezing food in a freezer is -10 degrees. Are these temperatures too warm or too cold? You go ahead and try these on your own. When you come back, we'll talk about it. Welcome back. So, -10 degrees, that's a whole number. So I'm going to try to make sure all of these are going to be in mixed number format. So -19/4, when I go ahead and make that L, that becomes 19 divided by 4. 4 goes into 19 4 times. So this is going to be -4 and something. It actually turns out to be -4 3/4. But the whole number is really all I need there, because I know that -4 is warmer. It's closer to positive numbers than -10. So this is too warm. Too warm. Look at that beautiful sun. -13.5. -13 is colder than -10 because it goes deeper into the negatives. And you know that when we get into negative temperatures, it's cold. So we get into more negative temperatures, it's going to be more cold. So that's going to be too cold. -50/3. Well, gosh, I don't know. That's going to be 50 divided by 3. 3 goes into 5 once. That's going to be 20. 3 goes into 20 6 times. We can see it's going to be -16 and something. It actually ends up being -16 2/3. -16 2/3 is past -10. So that's going to go ahead and be too cold. And then we have -4 3/4. -4 3/4 isn't reaching -10 yet. That's cold, but it's not as cold as -10. So even though it's a negative temperature, that's still going to be too warm. Ladies and gentlemen, go ahead and look at these extensions. That is the end of what I have. I hope that you have a fantastic rest of the day.